So here is our topic and our plan for today. First of all, we're going to talk about the real-world examples of Artec Studio's photogrammetry and phototexturing capabilities. We're going to have a short workflow demo. And finally, I will share some tips and tricks for getting the best results, including the filming process. So let's start off with the photo texturing part. So yeah, the photo texturing process is similar to photogrammetry. So we're hosting a single webinar for them. So let's discover the photo texturing first. So let's talk about what is photo texturing in general and in Artec Studio 20. So in simple terms, phototexturing in Artec Studio 20 is how we get stunning true-to-life colors onto our 3D scan. So while we use the exact geometry and shape of an object captured with our 3D scanner, we combine it with high-quality photos taken with an external separate camera. So the software then takes those external photos and matches them precisely to the positions recorded by your scanner. And the end result is a highly accurate 3D model wrapped in a vibrant photorealistic texture. So this way you're getting the best out of both worlds. So why do we need photo texturing in actual use cases? If you take a look at this slide, you could see two models here. The left one was created with the spider. The texture of the left model was created with the spider, and the texture of the right model was applied with the use of photo texturing. So if you take a closer look, you will see that glossy surfaces on the spider scan have some reflections baked into the texture, which is not ideally what we would want for the production-ready model. So it's best to avoid it. And one way to do this is to use the photo texturing. So if you take a look at the image on the right, we have a nice flat color on the surface, which is glossy on the spider scan. Then, of course, so you could see on the right that our object is brighter in general. So we are much more flexible when we're taking photos. We can use external sources of lighting here, which we use there. We used a light box in order to capture it, in order to evenly light our object. So of course, it's possible to use with the spider as well, but it's a bit more tricky because the spider has its own texture flash. So that is why it's much easier to do with the photo texturing. And finally, if you take a closer look at the model and at the texture which is applied, you will see that on the photo texture, the fabrics of our sneaker is way more defined on the photo texture. So we are not limited by the spider or actually any scanner like Leo Eva working distance, working scanning distance. So we can take close-ups, we can take photos in really high resolution which are taken closely to the model, to our object, and this way we're increasing the overall resolution of the object. So yeah, to sum up, we need photo texturing in order to increase the texture resolution, improve lighting conditions, remove shadows and glare with specific setups. Then, if necessary, if you're taking photos with an external camera, you could also perform color correction prior to applying the texture to your model. And finally, of course, you will get a photorealistic model within minutes this way. So here is a short guide on how to take images and apply the photo texture in Artec Studio 20. And let's start with scanning and taking photos. So actually the first step. We will talk more about the actual setup, which we used at the end of our webinar, because it relates both to the phototexturing and photogrammetry. So it's kind of it's kind of the same. So if you're filming for phototexture, first you need to place your object somehow. So you need to place it in upright position, make scan 1 in this position, and then, which is really important, you need to take photo set in the same position. So you need to take both the photos and your scan while the object remains in the same position. So it is crucial for the photo registration algorithm in order to match the scanner frames and the images from your external camera. So yeah, this is the best practice. So if you are filming your object and you need to scan it just in one orientation, then this is it. But if you need to scan the bottom part, the invisible part as well, then the next step is to flip your object, as you could see here, into position B. Here I laid it flat. So I put it flat onto the surface. And then I made scan 2 in this position, and I took another photo set in this position. So this way, we have acquired 2 photo sets and 2 scans. So then the next step is to import those photos that you've taken with an external camera into Artec Studio, and you will see them in the workspace, as you can see right here. So these are, first of all, we have scans. So as you can see right here, we have 4 scans taken with the Spider 2. Then we have 4 photo sets, which relate to those scans and to those positions. And then finally, we would need a fusion in order to apply the photo registration and the photo texturing. So the general processing pipeline is as usual. So once you have captured your scans, you need to run through the regular workflow, like alignment, eraser, registration, and create your final fusion, import your photos. And once all of that is done, you can move on to the photo registration part. So when you highlight those 3 objects in the workspace, so scans, your photos, and the fusion, you will see that the photo registration algorithm in the tools panel will be available for you. So you will see that the run button will be available, and this way you know that you have set the correct selection for your photo registration workflow. And here, so let's talk about the general settings here. Because they are really relevant for the best results. You see that we have just 2 settings under the general tab. So these are extract object from background and optimize for speed or quality. So optimize for speed or quality is pretty self-explanatory. If you need result as soon as possible, then it's better to select speed. And if you can sacrifice time for the best results, it's better to select quality. So I selected quality in this case. And as for the extract object from background, this option is responsible for masks. So when it is enabled, your object will be masked. So everything, so your background will be masked out, and only your object will be used for the photo registration process. So why do we need this setting? In this case, I turn it on because I've scanned this Crusader figurine when it was placed onto a turntable. So it was moving in relation to the background. When your object is moving in relation to the background, the best practice is to enable masks. But for example, if you're scanning a stationary object, if you're moving around the object yourself, and especially if you're scanning only in a single orientation, then you could leave this option off, and you will get a good result. So yeah, one more important thing to know to mention about this is that if you'd like for this option to mask out your images correctly, then it is better to keep your whole object in the field of view of your camera. So this way the masking will work the best. So yeah, once you have defined the settings, you can click the Run button and you will see, and here on the right, you could see the photo scan result, the photo registration entity. Essentially, it's a sparse reconstruction of your object, which actually can be used both for phototexturing and for photogrammetry. But here in this use case, we don't need it for the photogrammetry because we already do have the geometry collected with our Spider 2. So we're going to use it for texturing. So let's talk about the texturing then. So yeah, you will see once the operation is completed, you will see your photo registration entity in the workspace. And once you move to the texture panel, here you will see the photo registration entity as well. So you need to select your model to texture first. Then you need to select your photo registration entity as the texture source. So once that's done, you just need to specify the settings in this texture panel, and you can apply the algorithm. So yeah, let's talk about the most useful ones really quick. We will talk about them in detail a bit later on. So here, usually when you are filming with a camera, either a video or photos, it is great to use the prioritize sharp images option because as the title suggests, it prefers sharper images with better clarity over the blurred out ones, and this way, in most cases, you will be able to receive a much more defined texture. So you will be able to get a better resolution of the texture. So then you will be presented with an option to use masks or to whether use the masks or not. So yeah, if you have calculated the masks on the previous step, of course. And this option, you could turn it on if you see that there is some artifacts on your texture from the texturing step, then you could rerun the texturing with this option turned on, and it will ignore all the colors that surround your object. It will only use the colors within the masks for the texturing. And finally, you need to specify the resolution. So it totally depends on your needs. Generally, for such small models, depending on the resolution of your camera, of your photos, 4K should be sufficient, but you can go all the way up to 16K if you'd like. So now let's talk about an alternative approach for the photo registration here. Sometimes there are cases with difficult objects when it is not possible to create a single photo registration entity out of all of the photos. So in the previous workflow, we selected all our photos and all our scans and our fusion at the same time, so everything at the same time. And if our object has enough texture features, then it would work greatly. So if we're scanning our object in multiple different orientations and we mask it, and then the object itself has a great texture, then we could create just a single photo registration entity. But sometimes it does not work for difficult objects which have repetitive texture, which may have repetitive patterns or something like that. It may be a bit tricky. to create a single photo registration for them. So this is where the alternative approach comes to rescue. In this workflow, you create unique photo registration entities per site. The workflow is the following. You select the photos from the position A and the scan from position A, plus your fusion, and you create photo registration 1. Then for the position B, once you've, where you have flipped your object or moved it in order to scan the obstructed geometry, you create a separate photo registration. And you repeat this process for as many times as you'd like, so as many times as the orientations you have. And then you will have multiple photo registration entity in the workspace. Of course, they will be aligned because they use your scan as a base for the alignment of the photos. And then you could just select all of those free photo registration entities in order to texture your model, and all of them will be used and mixed for the final result. So this is an advanced tip how you can overcome difficulties with difficult objects. Okay, so now let's move on to the photogrammetry part. So let's talk really quick about what photogrammetry actually is. So originally, photogrammetry is a science and technology of obtaining reliable information and measurements from imagery, but in modern concept today, it has evolved dramatically. We now use powerful software to analyze dozens or even thousands of overlapping photos. And by identifying and measuring common features across these images, this software triangulates their precise positions of points in 3D space, allowing us to build highly detailed and accurate 3D models of objects, buildings, or landscapes from simple 2D pictures. In this case, we don't actually need a scanner. We can just use a photo camera or your phone in order to collect this imagery. Also a quick disclaimer about our AI photogrammetry. Let's talk about what does AI in the context of Artec Studio photogrammetry stand for. Actually, we don't generate 3D models from a single photo or from text prompts. We do not imagine objects and features. So we don't use, in this case, it's not the generative AI that we're using. And while generative AI is great for some applications, in our case, AI means advanced reconstruction algorithms that make photogrammetry faster, more reliable, and more accurate. So now that you know what kind of AI we're talking about, let's start by looking at some example results to see what's possible to achieve. So our core strengths of AI photogrammetry in Artec Studio is the ability to capture black, shiny, semi-transparent objects, featureless items, small to medium scale objects. So we can also capture large scenes, but our main strength is in reconstructing tricky surfaces of really small objects. And we can even work with low resolution images, so we can get pretty decent results even with low resolution images taken with your phone. And we don't require thousands of photos to reconstruct an object. Here is an example of a featureless object. So now I'm going to show you a few examples of what we can achieve, and then we are going to move on to the actual tips for the software for the processing. So here is an example of a skeleton hand that I've scanned with Nikon Z6 camera, just 77 photos, and I was able to receive a really nice result. So you could see that all the bones are defined greatly. We can see a very good transitions between different shapes. You could see that cavities are preserved really well, and the difficult geometry in holes is preserved greatly. So this is one of the examples of the featureless object that we can reconstruct with great 3D resolution. We can also, of course, digitize large objects with multiple devices. So here is an example of a monument that we've scanned in Lisbon. So here we've taken 300 photos with DJI Osmo Pocket 3 camera and some close-ups with the Sony camera. So on the left, you could see a close-up from the Sony camera. It was used in order to improve the quality of the inscription, to improve the resolution of this text. And then we used the DJI camera in order to capture the overall shape of the object much faster. So yeah, and our final model approximates at around 1.2 million polygons. So you could see it right here in a 3D render. So yeah, we could digitize that in just a few hours. We had a complete ready model, also with a texture, with a photorealistic texture applied from the camera. So yeah, here is one more example. Here is one more type of the object that we can scan. Here is an example of jewelry scanning. It's a small ring with really shiny, shiny surfaces and small details. Here we have quite difficult to reconstruct surfaces, but thanks to the AI algorithms for the photogrammetry in Artec Studio, we have been able to reconstruct it pretty nicely. So here you could take a look at the geometry of our object and at the final texture that we have received. So you could see that we even preserved the tiny holes between the geometry. We have the cavities preserved really great. Yeah, so we've managed to get a really good result in just around 130 photos. Yeah, so let's sum up. Let's quickly sum up the photogrammetry capabilities that we have inside of Artec Studio. We're able to capture almost any kind of surface. We have efficient data usage. We can capture and reconstruct rich geometry and apply ultra realistic textures to them. And of course, it's easy to use. So you will see a workflow demo in just a moment. Also, we have a complete webinar, a photogrammetry webinar, which features more example, and it's dedicated to the photogrammetry specifically. We will link that to the recording of this webinar, so please check it out if you are interested in photogrammetry in Artec Studio. Okay, so now let's move on to the dedicated algorithms for objects and scenes. Speaking generally, we have 3 different modes. We have 3 different reconstruction algorithms inside of Artec Studio. The first one is AI mode with without masking. So we recommend this mode for 80% of the cases. So generally, all the objects which you are scanning in a single orientation, which have small to medium size, for them, we would recommend to use the AI mode without masking. Then for tricky cases, for challenging tasks, we have the AI mode with masking. And finally, we have the classic mode, which is best suited for large scale reconstruction. Now let's take a closer look at the actual examples. So our default AI reconstruction mode, which does not use masks, is best suited for static objects, which are not moved between frames. So small to medium objects will be reconstructed the best. So the skeleton hand is a great example of a small object, which you could reconstruct with the AI photogrammetry. So then this mode supports close-ups. So if you would like to get a really good level of detail on some part of your model, you could take close-ups as well. Of course, the general plan is really important. So first you need to scan your object from a general plan to capture the whole geometry, to have your data for the registration of the photos, and then you can take close-ups to improve your finest details. So this way you will improve both the geometry output and the texture output. So yeah, and as I've mentioned before, here we don't use masks, so your object will be reconstructed with the surroundings, and then later on you could trim them easily in Artec Studio and optimize your model. So we'll go through this as well. There is one more approach that you could take. So here you could see on the example of this seashell, we have flipped it between the photo sets. So we have moved this object between frames. Therefore, and also we are scanning it on a turntable. So first of all, we flipped it, and then secondly, our object changes its position in relation to the background with each frame. So in those cases, when you're either using the turntable and or flipping your object using multiple orientations, we recommend the AI photogrammetry reconstruction mode with masks. So you could enable it by going by selecting the AI processing mode, and then you'll be able to highlight, to check the extract object from background option. This will enable the masking for your objects. And once again, this mode is best suited for small to medium objects, such as this seashell. I would say that this seashell in particular relates to small objects, so you could go even bigger than that. It's suitable for flipped and rotated objects, and it's suited for inconsistent background. For example, if there are people moving around, walking around, or if you are filming it on a turntable. And then finally, we have a classic mode for large scale reconstruction. If you take a look at this torch, it was scanned from a drone. So we used aerial photos, aerial imagery in order to reconstruct that. Yeah, if you have a drone dataset, a dataset of a landscape or a building that you would like to reconstruct, we would always recommend to go for the classic processing mode. So it will allow you to get the best results. Now it's time for a quick workflow demo. So yeah, don't worry about memorizing everything. You will get a full tutorial after the session. So let's take a look at the walkthrough. I'm going to use this skeleton hand, which was featured previously for the demonstration. So first of all, I'm putting it orientation. I'm making sure that it's evenly lit, and I'm using a camera in order to capture the images in a full dome around the object. Once I have captured the images, I am importing them into Artec Studio. And here you see that they are appearing in the workspace. and you can double click the entity to go through each one of them. Then you can go to Tools, Create Preview. Here, since we have filmed in a single orientation, we're going to go with a static scene for our preview, for our sparse reconstruction. Then once we go to the advanced settings, I'm going to uncheck the fast processing checkbox because I want to receive the best results and I have time for that. So then I'm clicking the Run button, and after some time, you have this photo scan entity. So this is your sparse reconstruction. And now it's time to adjust the bounding box. You just need to double click on this photo scan entity, and you will have those controls for the bounding box. And as you can see right here, I'm using the navigation cube in order to fine tune this area. So I'm choosing just the skeleton hand to be reconstructed. So everything that is highlighted in green will be reconstructed here. Then I'm going to Tools, Create Model. Here I'm selecting the AI processing mode. I am selecting the enhanced level of detail, which will be slower but produce the best results. And then finally, here I do not enable masks because our object has not moved. So we actually do not need the masks for our final reconstruction. And then I run the algorithm. So after some time, you'll receive this final polygonal model, which will look really great. So as you can see, everything outside of the bounding box is trimmed. Now I have, so I have some noise, I have some data which I do not need around my object. So I'm going to erase it with the eraser. And now I have only the necessary part. So once it's done, I'm going to mesh optimization. And here I'm running it. So I'm removing the small object and optimizing my mesh. So I'm reducing the amount of polygons. So you'll see this in effect. So here's what we have after, here's what we had before. So the size of the triangles is enlarged and our overall poly count is lower. So yeah, then I've textured the model and now it's ready for export. So then you can right click onto your model, click on export, export meshes, and here you can select your path. You can specify the path, the target folder, specify the model export formats. The most popular ones are OBJ and PNG, and then I can export it. So yeah, this is it for the reconstruction of your object. Here is your final result. So it's as easy as that. And in just a couple of dozen of minutes or around an hour, you get your first 3D model with the use of photogrammetry here. So let's walk through the main features of the AI photogrammetry. So first of all, in Artec Studio 20, we have introduced the workflows, and we provide this workflow with Artec Studio itself. So it comes preloaded. You will see right here that we have a complete workflow of the tools predefined for your convenience. So if you're new to the software, or if you're training a client who is not yet familiar with photogrammetry, you could just recommend them to import the photos manually and run this simple photogrammetry workflow. It has all the settings predefined, so they will work on most of the object. But of course, you could fine tune the options for each of the steps if you wish as well. One more feature that we've added with Artec Studio 20 is the ability to combine multiple cameras. Here you will see under the advanced settings for the Create Preview tool that now we have a camera grouping mode option, which is responsible exactly for that. So here you're presented with three options: auto, shared per photo set, and individual. So the auto mode is best suitable for when you are filming with just a single camera, which, to be honest, is the most common workflow. So it is set by default. And then we have two different options. Yeah, you should select the individual options if you import all of your photos from all your different cameras at the same time. So if you just drag and drop the folder which contains all the photos from different cameras, then once you are going to do the photogrammetry, it's best to select the individual mode. And if you divide your photo sets by the camera, then you should select the shared per photo set mode. So for instance, if you have one photo set from a drone and one photo set taken from ground with a different camera, and you import them separately by dragging and dropping those folders which are divided, then it's best to select the shared per photo set mode. The next feature that we have is you could find it, you can locate it in the texturing. So you will see the use masks checkbox, which we briefly mentioned earlier. And here is an example of this feature in action. So as you can see on the right, we have a texture artifact on our clock model. So there you could see some white color bleeding from adjacent geometry, from adjacent texture that we had. And ideally, of course, we would like to avoid that. And in order to fix this sort of issues, I would recommend to try to enable the use masks option, which will be available in case you've calculated them before. Then another really convenient feature that we have is called prioritize sharp images. Here are some examples with this option turned on versus off. So on the left image, you could see that the chest plate is quite blurred out. You could see that, yeah, the texture is not that well defined. So that happened because we had quite a few photos where it was blurred. And in order to fix that, we're just going to enable the prioritize sharp images. Let's say set it to 4, which is the default option. And here on the right, you will see that we have a much sharper texture with a better clarity. So essentially what this option does, it goes through all of your images in your photo set, in your photo scan, and it chooses, it has an algorithm to choose the sharpest ones, the ones with the best clarity. So then it will, those photos will have a higher priority, and the ones that are blurred out will be used for if there is not enough data on the sharp images. So I would encourage you to experiment with this setting a bit. So I cannot give you like really really precise advices of which level of this option you should choose. It is unique for each of the photo sets, so feel free to experiment with it. If you see that you've selected a value too low, let's say, or too high, then you could reuse, you can highlight the reuse UV map option and run it with a different weight, run this setting with a different weight to find the best result for your specific use case. So yeah, and one more thing that I would like to mention about this setting is that you shouldn't really use it if you have a really limited amount of photos. So if you don't have enough photos, let's say just a random number, if you have 30 photos for your whole object, which is small, even if it's small, then it's better to keep this option off. Because this way you will start seeing some seams between photos because the ones that may be blurred out will be less prioritized. So yeah, this option works best when you have enough photos. So let's say for a small object, having 60 plus photos will be enough for this option to function correctly. Okay, so now let's talk about the scale bars and using them for measurable results. Before we have created just beautiful models out of our geometry, but we didn't apply real world geometry scale to them. But in case we would like to receive a better accuracy, a correct scale of our object, then we could use the scale bars and scale crosses either. So yeah, you could use different ones, and we also do provide a scale cross with Artec Studio in a PDF file, which you could just print out, place into the scene, and use it for reference. Yeah, let's see how it works. So this is the PDF file that I've been talking about previously. This is the file that we provide with Artec Studio. You could just print out this Artec scale cross photogrammetry reference. We have it in US format as well. Here I have it in EU format. So yeah, you could print it out depending on the type of printer that you have. And then you need to place it into your scene next to your object in a way that this scale cross will be visible from a variety of different angles. Ideally for the scale cross to be detected and for the scale procedure to succeed in order to get a measurable result, a result which is scaled correctly, you need to have at least 10% of your photos with the full scale cross or full scale bar visible. So I'm emphasizing full scale cross because yeah, from some of the angles, it won't be possible to see all of the 4 targets. So you need to have 10% of your images with 4 targets visible at the same time. So this way you're going to get the best results. And of course, the more the better. So the more photos you have with those targets visible at the same time, the better. Of course, due to a certain extent. But generally, it's a good practice to have as much of your photos with the full scale cross or scale bar visible. So yeah, and in order for the proper reconstruction, you also need to make sure that your whole object is in the field of view of the camera as well at the same time, as you could see right here. Here on the slide, there is a good example of this statue, which is fully visible at the same time the scale cross is fully visible as well. So yeah, don't worry about the QR codes or text on it. It's just for your reference. The most important thing that we need to see are those targets. And also, if you take a look at those red crosses on your scale cross right there, you could use them in order to confirm that your scale cross was printed in correct scale, actually. So yeah, you could just take a ruler and measure the distance between those red crosses, and you can match it with the reference distances provided on this list. And then this way you will be sure that you have the correct scales on your cross, and then that they will be applied to your object correctly. So yeah, this is a way of using scale bars and scale cross in this case for measurable results. As you could see, you can really do real world engineering with just your phone and Artec Studio in cases when accuracy, a sub-millimeter accuracy is not your highest priority. So of course you will be able to achieve a better, more accurate result with a scanner such as Artec Point, let's say, or Artec Spida, Artec Eva. This way you will be able to receive a measurable result which has a proven accuracy. In case of scale crosses, we cannot guarantee the accuracy at all times because it highly depends on the way that the photo set was taken. So it requires a high skill from the operator. But still, if you need, let's say, millimeter accuracy for some hobby application for 3D printing, let's say, then you could easily use the scale crosses for that purpose. So, for example, here I have scanned this Buddha statue with our Artec point scanner. And here you could see a distance map between the Artec point model, which is used as a reference of good accuracy with our photogrammetry model. And as you can see right here, we have quite good results. So these are the results that we received with the scale cross. The highest error that we have seen here is around 0.8 millimeters. Yeah, and in areas which have a lot of features, we actually have quite good and quite accurate reconstruction. So this is one more important part about the photogrammetry, that it requires features. So the more features that you have in some particular area, generally the better accuracy you will be able to achieve there. So now let's move on to the next part. And even though our software handles most things automatically, a few simple techniques can significantly help you to get the best possible results. Now let's talk about filming, about your setup, and how to get the best results, both for the photogrammetry and phototexturing. So, of course, the phototexturing and photogrammetry process begins with the scene preparation first. So firstly, there are 4 general rules that we recommend to follow. First of all, it's really important to have an even soft lighting on your object. So if you're scanning small to medium objects, then you could use a light box, let's say. And if you're scanning outdoors, then it's best to wait for the overcast, cloudy weather. This way, like your whole sky is one large light box, and you will get an even lighting on all of the sides of your object, and it will be easier to work with it. So then, of course, it's important to have sufficient feature capture. We also do recommend to try to achieve sharp images, both when you are filming a video or taking photos. It is equally important. And ensure that you get all the angles and use a good trajectory. More on that a bit later on. So, of course, photogrammetry is not able to guess the geometry if you don't have photos for that particular area. So for the full coverage and for the best reconstruction possible, more angles will be able to provide a better triangulation, better position of the camera poses, and then the better reconstruction of your 3D model, which is ideally what we want. So yeah, now let's talk about these points in depth. About the lighting. So here we have kind of a bit of exaggerated results, exaggerated examples on the right, but they convey the idea really greatly. So yeah, and the good lighting, we have on the good image, we have an even lighting. We don't have excessive glare. Our object is not too bright on our photo, so we have adjusted the ISO and general exposure in order to get a good even color without losing any of the color details. We are avoiding shadows, overexposure, glare for the best results. And if you are filming outdoors, it's also important to avoid to prevent the lens flare. So yeah, if you're filming against the sun and if you have lens flare, then those images can be really bad for the reconstruction. So they can worsen the alignment of the photos, and they can produce artifacts on your final model. Yeah, this is a simple standard setup that you could recommend for small to medium objects. Very convenient that You could use them for the with the AI photogrammetry mode specifically. So yeah, here it's easy to achieve even and soft lighting. So ideally, you would want a larger box in order to get a better diffused lighting. So it's important to have enough features. It's important to collect sharp images and to capture your object from enough angles and good trajectories. So Lightbox allows for that. It's kind of an easy way to do your photogrammetry. So you just put your object onto a turntable. You could use the Artec turntable for that, which is automatic. You could launch the turntable and start taking your video or your photos. And this way it will be easier for you not to forget any angles and get a good trajectory. So now let's move on to the next point. Now let's move on to the features. So you could see on the example at the top, an example of a rich texture. You could see that we have a lot of different colors with some unique pattern. So all of the photos will be easy for the algorithm to distinct them, and it will be easy to register to combine this object. Also, it's not completely symmetrical, which also helps us. It has some imperfections, both on the geometry and the texture. So this is perfect for us. So such objects do not need any extra preparation. You could film them as is, and you will get really good results. And as the counter example at the bottom, you could see this motorcycle frame, which has a poor texture. So generally it's made just from a single material. It has this paint, which single paint, single color, which does not have as much imperfections. It's symmetrical. So such objects, it's more difficult to reconstruct because yeah, it will be more difficult for the algorithm to match those photos. So how can we avoid that? How can we help the algorithm? First of all, if you see that your object has just a single color, it does not have enough features, you could add a texture background to it. So you could just print out some random unique text on a sheet of paper. You could put it underneath your object, and you could use it as an aid for the photo registration or as an aid for the photogrammetry. So yeah, in case of photo registration, it's important to mention that it should be present both on your scan and on your photo set as well, for the photos to be matched correctly. On the photogrammetry, yeah, of course, you're just taking a single photo set with an external camera. So yeah, this is kind of a way to reconstruct tricky single color objects. Then let's talk about sharp and focused photos. Here it's pretty simple. You would like to have your whole object within the depth of field of the camera. So adjust the settings of your camera, adjust the focal length appropriately. And adjust the distance which you use to take the photos from for that, in order to have the whole object in the field of view of the camera, and it should be sharp. So you see a better example right here, which can potentially worsen the reconstruction results. You would generally prefer to avoid motion blur and have a good level of detail in your photos. So try to avoid like extreme values of ISO. Try to avoid once again overexposure, to have a good color distinction and to preserve the original color of your object. So now, as for the recommended trajectory for the photogrammetry, Ideally, you would want your photos or your video to cover all the angles, your object from all the different angles. Generally, we recommend to scan it in a dome-like shape, as you could see right here with this bicycle example. You would like to avoid blind zones in order to reconstruct your object fully. And finally, ideally, you would want a good overlap between photos. So a good rule of thumb, if you're scanning on a turntable, it's best to take a photo at each 10 degrees of rotation. So this way, at a single height, if you're filming on a tripod, you will have 36 photos per a single height. So yeah, you could scan your object with two different heights. So let's say height 1, height 2, and 36 photos per one height. And this way you'll have around 72 photos in general, which is kind of good for small to medium objects. So yeah, this is a good rule of thumb to get you started. And then once you have more experience, you will be able to adjust this trajectory for your specific objects to get the best out of it. So yeah, if you apply all of the recommendations that we had, you can get a really nice model with photogrammetry just by using your phone or a camera. And of course, you could get a really vibrant texture for the photo texture to apply it to a model created with your scanner, with your Spider 2, Leo, Eva, and so on. So yeah, this way you'll be able to get the best out of both worlds, to get a really precise geometry with high resolution and a really nice texture with vibrant colors, which is still true to life. And finally, our last topic for today is combining photogrammetry and scanners. So here is a scene of a tower that was scanned in Luxembourg. So here we have combined the Ray 2 with photos from a drone. So we've combined aerial images with the Ray 2. And actually here we combined both the geometry, and applied the photo texture from our drone in order to get the best results. So as you can see right here, this tower is pretty tall. So it's not possible to capture it easily with the Artec Ray 2. We would need to elevate it really high. And also, as you could see, some of its part is inaccessible from the sidewalk, so it's not possible to scan it because yeah, it's located on a bridge. So we are not able to scan with the Ray 2 from this cliff area. Therefore, we use drone for that. So yeah, we overcame the limitations. We used the high resolution geometry from the Artec Ray 2, and we've added in the missing geometry with the drone. And then finally, we applied texture from a drone to get a really nice result. So yeah, as you could see right here, we combined 3D scans plus only 111 photos extracted from a drone video, and we received a model with a poly count of 2.5 million. So yeah, before showing you the model, let me describe our workflow really quick. Yeah, generally, how did we do it? First of all, we processed our ray scans and we created the incomplete ray model. Then we created a separate photogrammetry model from our drone. We've aligned the duplicate of our ray model to photogrammetry model with the allow scale option turned on in Artec Studio. So this way, we've aligned them properly in the coordinate system and they had exact same scale. We've created a combined fusion using those two meshes. And finally, so this way we've received a combined fusion of all of this data. Now we have a single mesh for that. And finally, we textured it. Yeah, we've textured it with photogrammetry. This way we've received the colors. But as you remember, we have changed the scale of our model. Therefore, we need to change it back now. So now with allow scaling option turned on, we align our final fusion, our final combined fusion to the initial ray model to get the correct scale. And here is our result. So let me show you a video of the render really quick. So here is what we have. Yeah, so we have a really nice model right here, a complete, our complete object with the photogrammetry, with the photo texture applied, and we were able to preserve the final level of detail scanned with the Ray 2. So yeah, it's kind of the best possible quality that we could receive in this case. All right, so thank you for watching this webinar.